Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on correlation, and this is an introduction and part 2 of this particular PowerPoint. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this set of videos, and will apologize if the ending of part 1 is extremely rough. I decided at a bad cutoff point to end that video. We will pick up here on talking about positive and negative slopes. As we talk about positive slope, first of all, notice as you look at the line moves upward as you move from left to right. If you follow this with your finger from the left side of the page to the right side of the page, you are moving in an upward motion. And for lines with a positive slope to stay on the line, as the x value increases, the y value does what? It will increase. So x increases, the y value increases. What happens if the x value decreases? So as the x value moves smaller, what does the y value do? It will also move smaller or decrease. So as x increases, y increases. As x decreases, y decreases. For a positive slope, the x and y values do the same thing. The same thing is for positive slope. Notice the underlines there. That will help you remember. For positive slope, the x and y are doing the same thing. Another way to help me remember it is I think of like a husband or wife or boyfriend and girlfriend if you have the same opinion. If the husband and wife both like something, it's a good thing. It's a positive thing. If the husband and wife both dislike something, that's a positive thing. They're both agreeing it's a positive thing. Say for a movie, if you're trying to decide which movie you like. If you both dislike the movie, that's good. Neither one of you want to watch it. If you both like a movie, that's a good thing. You'll want to watch it. And it's a positive thing, no fights. Here is a negative slope. Notice as you look at the negative slope and move with it from left to right, you are going down on your paper or on the screen as you move from left to right. So that is a negative slope. And for lines with negative slope, to stay on the line, as the x value increases, what is the y value doing? To stay on the line, what does the y value have to do? The y value decreases. So the x increases. This time the y value is doing what? It's decreasing. And as the x value decreases, as the x value gets smaller, then the y value is getting larger. It's increasing. So we have the x increases, the y decreases. The x decreases, the y increases. So for a negative slope, the x and y values here do the opposite things. As x does one thing, the y does the opposite. And again, notice the underline. For negative slope, they do opposite. For positive slope, they did the same. For negative slope, they're going to do the opposite. And back to my analogy of a married couple or boyfriend-girlfriend, if you're trying to decide on a movie to watch, if you both like the movie, it's going to be a positive thing. But look at this situation. If one of you likes the movie and the other one doesn't like the movie, what are you going to do? Well, you're going to be in a negative situation because you're going to have a fight about it. So it's a negative situation, and that's how I keep it straight in my head. Now, again, the fact, the sign of the slope and the sign of the correlation coefficient are the same. So if the slope A is positive, we also know that the correlation coefficient R is positive. And our equation will be y equals AX plus B, where A will be our slope. And in a negative sloped line, if slope A equals a negative sign, then our correlation coefficient R will also have a negative sign. The correlation coefficient is positive, then the sign of the slope is positive. Remember, the sign of the slope and the sign of the correlation coefficient are the same. So if the correlation coefficient is positive, the sign of the slope is positive. R is positive, slope is positive. For our second question, notice this. If the correlation coefficient is positive, as x increases, what is the y value doing? For positive slope and positive r values, x and y do the same thing. So as x increases, the y value increases. X goes up, y goes up. Look at question 3. If the correlation coefficient is positive, so we're in a positive slope, positive correlation coefficient, the x value decreases, what does the y value do? Positive means they're moving in the same direction. So as the x decreases, the y value decreases. As x goes down, y goes down. Let's look at this example. Would you expect the following to be positively or negatively correlated? X is the amount of rainfall, and y is the depth of water in a river. Are they moving in the same direction? As the x is the amount of rainfall, as the amount of rainfall increases, would we expect the depth of the water in the river to increase or decrease? We would expect the depth of the water in a river to increase. The amount of rainfall increases, the depth of the water in the river increases. So it is positively correlated because as x increases, y increases, and they're moving in the same direction. Fact: the sign of the slope and the sign of the correlation coefficient are the same. So if A is positive, R is positive as the correlation coefficient. And if R is positive, the slope is positive. If x increases, y increases. If x decreases, y decreases. If the correlation coefficient is negative, then the sign of the slope is negative. The sign of the slope and the sign of the correlation coefficient are the same. R is negative, then the slope is negative. If the correlation coefficient is negative, as x value increases, then the y value decreases. Remember, if the correlation coefficient is negative, x and y are doing opposite things. So if the x value increases, the y value must decrease. As x goes up, y comes down. If the correlation coefficient is negative, as x decreases, the y value, well, it's a correlation coefficient. This time is negative, so they are doing opposite things. So if x decreases, the opposite of that would be that the y value increases. As x goes down, y goes up. Let's look at this example. Would you expect the following to be positively or negatively correlated? X is the number of miles driven with no stops. Y is the gallons of gas left in the tank. So let's imagine X being the number of miles driven with no stop increasing. As the number of miles driven with no stop increases, would we expect the gallons of gas left in the tank to increase or decrease? We would expect the number of gallons of gas to decrease. As the number of miles driven increase, the number of gallons decrease. Since they are doing opposite things, they are negatively correlated because as X increases, the Y decreases. So we have our negatively sloped line, y equals ax plus b, and if the slope a is negative, the correlation coefficient r will also be negative. That means as x increases, y decreases. As x decreases, y increases. They are doing the opposite things. For a class discussion and as to conclude part 2 of this PowerPoint video series, let's explain why the first variables are positively correlated and the second variables are negatively correlated. Remember, in a positive correlation situation, as x increases, y increases. So does the amount of rainfall increasing mean the depth of water increases? Yes, they have to be doing the same thing. Does it work conversely? If the amount of rainfall decreases, does the depth of the water decrease? Yes, the less rainfall we have, the less depth of the water in a river we would have. Let's look at the negatively correlated situation at the bottom of the screen. The number of miles driven increases, the number of gallons left in the tank decreases. The fewer miles we drive, the more gas we have left in the tank. So that is doing the opposite, and therefore we are negatively correlated. Here is a class assignment for you to try, and because we are asking you to come up with your own examples, I can't give you answers here, and we will pick up with some additional examples on correlation in the next video or next part to this video set. Thank you for watching.